Okay, when we use numbers in a calculation, we can end up with lots of extra digits. And so we use significant figures to round the result to reflect the precision of the measurements that we started with. Sometimes we have multiple steps. We'll add two things together and we get a result, and then we multiply that by something else, then we divide it by something else. We don't round it off until the very end. If you round each step, you can sometimes introduce a lot of error in your result through rounding. So we don't want to round off until we get to our final result. So here are the rules for calculations with sig figs. There's a rule for multiplication and division, and there's a rule for adding and subtracting. So if you're multiplying or dividing, the result has the same number of significant figures as the factor with the fewest sig figs. So you're going to look at the numbers that you started with, and identify how many significant figures does each of those have. So 5.02, how many sig figs? 3. 89.665, how many? 5. 0.10, 2. So you do the math, you write down the answer, and then you look, how many sig figs did each of the factors have? Which one's the smallest? The smallest is 2. So then my answer can only have 2 significant figures. So I'm going to keep the 4 and the 5, and I'm going to say that the answer here is 45. Recording the whole thing, 45.01183, is misleading, because I only had 2 significant figures for that number. Here's a division example. There should be a 0 there. Not sure why there isn't. So we do the math, we get this number. To round that, we're going to look back at how many sig figs does each of the factors have. 5.892, how many sig figs? 4. 6.10. 3. Trailing 0 is significant there because there's a decimal point. So then we're going to keep 3 sig figs in our answer. This 0 is just there to call attention. So we've got 9, 6, and 5. We're going to keep that place. We look at the next digit, and that's 5 or larger, so we need to round up. This number is actually closer to 0.966. And so we're going to round this and call it 0.966. Any questions? When you round, you're only going to use the next digit that's getting dropped. You're not going to go start at the end and work your way back. You're just going to keep it simple, just do the next digit. So if the digit that you're dropping is 4 or less, you round down. If the digit you're dropping is 5 or more, you round up. And again, only round the final answer. So if we're rounding 2.33 to the 10th place, and I frequently use an underline to represent the last significant figure. We're going to look at the next digit. That's a 3, it's less than 5, and so we round down, and so the result is 2.3. Rounding 2.37 to the 10th place, the next digit is 7, and so we round up and we write this as 2.4. Forgot my calculator. It's okay, I got a cell phone. So perform the following calculations to the correct number of significant figures. So what we want to do here is do the math first and write down what the calculator shows us. So 1.10 times 0.512 times 1.301 times 0.005 divided by 3.4. And I encourage you to bring your calculator to every class and do these calculations with me. Because I screw up sometimes, and it's really fun to tell me that I'm wrong. It's really easy to make a mistake when you do a calculation like this. You get one digit wrong in the calculator and your whole answer's wrong. So I recommend doing doing this on your calculator twice. Did anybody else do this and get that same result? I got a couple nods. Okay, so you're my check. So that's what the calculator gives me. That's way too many digits. So what I need to do is I need to go back and look at where did those numbers come from? How many sig figs does 1.10 have? 3. How about 0.512? 3. 1.301? 4. 0.005? 1. Leading zeros are not significant. 3.4, that's 2. So the smallest number of sig figs is 1. I need to round this to one significant figure. The leading zeros are not significant figures, so I'm not going to count those. I'm rounding to the first non-zero digit. And I look at the next digit, that's less than 5. And so I'm going to say this is 0.001. I rounded it to one significant figure. Any questions? Let's do the next one. 4.562 times 3.99870 divided by 89.5. Calculator says 0.203822. Anybody else get that? Yeah, okay. So, it's good practice to identify how many sig figs in each of those and write them down. Really all you have to do, though, is look to see which is the smallest. So let's try that method here. Which of these has the fewest number of significant figures? The last one, 89.5. So that has 3 sig figs. So then our answer has to be rounded to 3 sig figs. So the 0 at the beginning is a leading 0. We don't count that. We've got the 2, 0, and 3. We're going to keep 3 digits. 0.203. We look at the next digit, the first one that we're getting rid of, to see if we round up or down. And so this is going to round up, and we're going to report this as 0.204. Adding and subtracting is a different type of operation, and so it requires different rules. So here we're looking at the number of decimal places. So the result carries the same number of decimal places as the quantity carrying the fewest decimal places. So multiplying and dividing, we're looking at number of sig figs. Here we're looking at number of decimal places. So here we've got 5.74 plus 0.823 plus 2.651. And I'm getting 9.214. That's not right. I screwed up. 5.74 plus 0.823 plus 2.651. No, I was right. Okay. 9.214. So the rule says fewest number of decimal places. So this number 5.74, decimal places are the places after the decimal point. So how many decimal places does this one have? 2. And how about this one? 3. And this one has 3. So 2 decimal places means I'm going to round this to 2 decimal places. I'm going to keep 2 decimal places. I look at the 4 and decide that I should round this to 9 point. That didn't go very well. Nine 9.21. So another way to think about this, I'd like you to understand why this rule works. The last digit in each of these numbers is uncertain, right? So the 4, this 3, and this 1. Those are the uncertain digits. When we do the adding, Here it's stacked up so that we could add it by hand without a calculator. We're adding a blank here, which we treat as 0, but do we know what that digit is? We have no clue. So we'll assume it's 0. And here we have a 3 that we're uncertain about, and a 1 that we're uncertain about. So we add the 1 and the 3, and we get 4. Is that 4 certain or uncertain? Uncertain. That's very uncertain. So that's not certain. That's an uncertain number. And then the next column, we've got a 4 that's uncertain, estimated, plus 2 plus 5. Well, the 2 and the 5 we're sure about. So that's 7 plus 4 gives us 11, but because we're adding an uncertain 4, we can't be sure about the 11, right? So that makes the 1 uncertain. So we carried a 1 from the 11, so we've got 7, 8, and 6. Those are all certain numbers, plus the 1 from the carryover, and so that gives us, what, 22? But that 2 is certain. There wasn't any uncertainty in the numbers that we used to add that. And so when we look at this result, we keep all of the certain digits, the 9 and the 2, and the first uncertain digit. So here's another way to think about that one. Stack them up like that. Draw a line just to the right of the number that ends first. I didn't write my answer down there very well. So this number ends after the second decimal place, and so I'm going to draw this line, vertical line, showing 2 decimal places. Do the math, and then where that line is, that's where your number ends, your result ends. So there's 3 different ways to think about this. Okay, let's do this one. 4.8 minus 3.965. And the calculator says 0.835. So how should I express the answer? Well, how many decimal places does the first number have? 1. And how many does the second one have? 3. So 1 is the smallest number of decimal places. So then the answer should have 1 decimal place. So the answer should be just 0.8. There's uncertainty in the first decimal place. And so when we add this to the 9, there's uncertainty in the result, or subtracting, sorry. Any questions? You guys aren't asking nearly enough questions. Sometimes in adding and subtracting, you can have more digits, sig figs, than you started with, or you can have fewer. So in this example here, this one had 2 significant figures, and this one had 4 significant figures. The answer ended up with only 1 significant figure. That's because we're not counting sig figs when we're adding and subtracting. We're counting decimal places. Let's do this example, 28.02 minus 27.99. And a calculator gives me 0.03. So it's subtracting. We should count decimal places, right? So this one has 2 decimal places. This one has 2 decimal places, and so my answer should have 2 decimal places. So this time my calculator gave me the right rounded number. It only has 1 sig fig. It's okay. It's the difference between numbers, and so it can have very small number of significant figures. Okay, let's do these examples. So you do the math first, and then you worry about the sig figs. Screwed up. This is why I don't like using my cell phone. Okay, so my calculator is giving me 7.488. How should I round that? One decimal place. So we look at the numbers that we were adding and subtracting, 2, 3, 4, 1 decimal place. So I'm going to keep 1 decimal place. And the next digit is an 8, so I round this up to 7.5. It's a good practice to write the whole number down that your calculator gives you, and then write the rounded one. So let's do the one on the bottom there. 7.876 minus 0.56 plus 123.792. So the calculator is saying 131.108. What should I round it to? 2 decimal places. So 131.11. So I'm going to keep 2 decimal places. Adding and subtracting is decimal places. Multiplying and dividing is the number of significant figures. Sometimes we have calculations where we've got both types of operations. So there what you want to do is you want to follow orders of operation. So if there are parentheses, you're going to do what's in the parentheses first. That'll give you an intermediate value. You want to look at the intermediate value, perhaps write it down, figure out how many significant figures it should have, but do not round it. Use the whole thing, finish the calculation, and then look at rounding the final answer. So this really requires examples. So here we have an example where we have multiplication and we have subtraction. So we're going to do the part in the parentheses first. So I've got 782.3 minus 451.88. And it's helpful to write that value down. So that's 330.42 is the result of the subtraction. And here's where using the underlining technique to identify the last sig fig, the first uncertain digit, is helpful. Because when I'm subtracting, I'm looking at decimal places. Here I've got 1 decimal place and 2 decimal places. So this has uncertainty in the first decimal place, the 4. But I don't want to round it. I want to keep the whole number, and then I'm going to do the multiplication. So times 3.897. And then I'm going to write down what my calculator gives me, which is a big mess. 1287.64674. Way too many sig figs. What I'm looking at now is this number times that number. How many sig figs does this one have? 4 significant figures. Because I'm multiplying now, I want to count significant figures, not decimal places. So this number, I didn't round it, but I indicated which was the last significant figure. So this one has 1, 2, 3, 4 significant figures. Okay. So I've got 4 sig figs and 4 sig figs. So my answer should have 4 significant figures. So I'm going to keep 1287 first 4, and then the next one's a 6, so I need to round, and so I'm going to call this 1288. Four significant figures. You can't come up with the correct number of significant figures here without looking at that intermediate result. Let's do this one, 4.58. Come on. 4.58 divided by 1.239. I'm going to write down what that is. 3.69652.946. Oh, that's a mess. Here I'm dividing. Division, we're looking at number of sig figs. So this is 3 sig figs, and that's 4 sig figs. So this result should only have 3 significant figures. So it will be right there. I'm not going to round it, though. I'm just going to leave it alone. It's in my calculator, and then I'm going to go ahead and subtract, so I don't have to type all that back in. I'm going to subtract 0.578 and write down the result, 3.11852.946. My last operation here was taking this number and subtracting that number. When I'm subtracting, I'm looking at decimal places. So this number, I underlined the last significant figure. So this has 2 decimal places. The rest of that is just stuff that I'm carrying along. So 2 decimal places, 3 decimal places. So I should round this result to 2 decimal places. So that's going to be right there. And I look at the next digit to figure out how to round it. And so that result is 3.12. Any questions? Significant figures tend to be difficult for Chem 3A students. There will be questions on the first exam and on the final exam that are specifically to identify whether you understand significant figures. For the rest of the course, I'm going to demonstrate them in lecture. I'm going to use them. I want you to do your best. Try, okay? What's more important than getting exactly the right number of significant figures for Chem 3A is that you have an understanding that what your calculator tells you is sometimes got a lot of garbage at the end. Okay, so try to get close to the correct number of significant figures.